The Atlanta neighborhood of Blandtown was named after Felix Bland, a freed slave who was willed the land surrounding Huff Road after the Civil War. Huff Road, the main road, also takes its name from a prominent family from Blandtown's past. Blandtown grew from farmland into a vibrant African-American community around a developing industrial mill district. The original wooden bungalows of the neighborhood are now gone. Annexed by the city in 1952, it was rezoned as an industrial area in 1956. This marked the end of Blandtown. Attempts to have it rezoned back into a residential district in the 1980s were defeated by large industrial companies, namely Nottingham Chemical. Blandtown is still zoned as an industrial area, but now most of the industry has relocated to other areas in the city, leaving many buildings on the existing site abandoned or underutilized.
In the last 20 years, a new demographic has appeared on site. The light industry has been replaced by the design industry that has taken advantage of a plethora of space given by vacant industrial buildings to use them as showrooms or inventory for high-end designer items. Along with this group are young professionals who, drawn to various hip restaurants and clubs in the area, have sparked new development as part of the growing West Midtown area. New apartment communities provide housing for these young professionals, but they are turned inward and poorly activate the streetscape. The diversity of occupants can grow to further utilize the site if there were not environmental problems left on site from its heyday as an industrial district.
Due to the light industries that have polluted the site, the EPA has declared it a brownfield. Sustainability and the local ecology are central issues of the site and therefore this project. In order to make the area safe, several steps of remediation taking an estimated 30 years will have to take place. The first step is to match and introduce plants that are effective in removing each of the toxins. This 4-phase remediation process will restore the soil and release land for development. During the remediation process, the natural streams in the Woodall will be represenced, allowing the natural ecology to be restored and preserved around the streams.
Incorporating sustainable technologies was also part of the overall strategy. These included solar, piezoelectric, and water management systems. In examining the amount of energy used by the average household, we found that a typical individual family unit uses an average of 11,500 kilowatt hours per household monthly. This approximates to 138,000 kilowatt hours per year. We determined that it would take 6,300 kilowatt hours of stored solar energy to power 2,300 square feet, the size of an average household in Georgia. Tall buildings have much more energy consumption and therefore require 18,000 square feet of solar energy panels for an 11,000 square foot of occupied space.
Another renewable energy source used were algae trees. Algae trees are actually artificial structures designed to replicate the natural process of an actual tree in areas designed for human occupation. Algae trees utilizes photosynthetic properties of microscopic algae by capturing sunlight, water, and carbon dioxide in order to produce biodiesel and generate electricity through the use of underground generators. The algae trees range from 18 to 20 feet in height and 24 feet in canopy span.
Another renewable energy source utilized throughout the site is piezoelectric energy collection. Piezoelectricity consists of electricity generated by the pressure of the tiniest vibrations into an energy collection source. While Georgia is not windy, areas that are densely populated with vehicular traffic or rail lines provide enough wind gusts to activate a piezoelectric windstalk or fabric screen. 270 square feet of piezoelectric fabric used as a building skin can create 34,000 kilowatt hours of energy per day. That is enough to reduce energy consumption of the large buildings on site by 26%. The master plan incorporates a piezoelectric field in the southeast quadrant between the rail lines. The long mixed-use megastructures are also skinned with piezoelectric screens along the facades that face the tracks.
Sustainable water management was also important for the site. The average American is estimated to use 25,000 gallons of water per year. This means for the 15,000 inhabitants, the district will require 383 million gallons of water annually. In Georgia, the annual rainfall is 50.2 inches. This roughly translates to 31.12 gallons per square foot. At 13 million square feet, roughly 395 million gallons of rainwater falls on the site, a sufficient amount to meet the residents' needs. Our strategy called for capturing, filtering, storing, and reusing as much water as possible. The master plan incorporates approximately 100 million square feet of water gathering area, feeding the water collection and purification tanks throughout the site. This amount of annual water collection can reduce the need of external water by 50% for the entire 15,000 occupants. The stormwater management system will collect street water runoff, purifying it through a natural vegetation and soil filtration system before going into the waterways that feed the Chattahoochee River.
For a more subtle, yet constant water collection, fog catchers are strategically placed throughout the site. With this method, the humidity in our climate can be used to our advantage. Fog catchers are composed of a mesh fabric that collects dew in the atmosphere and allows it to trickle down to a cistern at the base.
Green roofs are also a component of stormwater management. Not only do they utilize water that falls onto the roof to nourish the plant life, the green roofs also naturally filter and provide gray water for the building once the water collected and used for plant life reaches capacity.
Caroline Steele's lecture, How Food Shapes Our Cities, presents the argument that there is a huge need for farming within the cities so that individuals may maintain a replenishing and healthy diet. To complement the sustainable energy systems, we decided to incorporate urban farming, which will provide approximately 40% of food source for the occupants. Two types of industrial agricultural infrastructures were used to address the needs of food sustainability in this district: the rooftop promenade and the vertical farming towers. The roofs of the megastructures are dedicated predominantly to industrial agriculture. An extensive promenade provides visibility and access to the production while simultaneously providing panoramic views of the area. To supplement the megastructures, vertical farming towers were also used. These vertical green structures act as gateways into this district and signify the change from the existing culture to one that is more sustainable.
The site contains several distinct topographical features that were taken into consideration in the master plan. Steep slopes along the edge of the Udall presented roadway, development, and accessibility challenges. In these areas, we incorporated single and multi-family housing that stepped down the slopes like fingers, holding the natural landscape. These defined areas for pedestrian paths that move alongside the topographical changes into the Woodall.
There are very steep areas growing outward from the low-lying waterways. These steep areas have to be addressed one by one in the overall design. Blandtown is surrounded by two major rail yards that provide the initial perimeter of the site. The rail lines provide a unique curved boundary and act as a large barrier against connectivity with the rest of the city.
The current vehicular connections over the railroad lines are Huff Road and Marietta Boulevard. These are maintained as arterials to the site in our proposal. Huff Road is currently not sufficient for either vehicular or pedestrian access through the site. To address this issue, we propose to change it from a 2-lane road to a 4-lane road, improve pedestrian access, and introduce mass transit lines.
As the density increases, we propose to improve Ellsworth Industrial Boulevard to support the growth of the district and allow for the arterials to breathe during peak traffic hours. Finally, we have pulled Herndon Street north through our site and connected it to Chattahoochee Avenue to provide a third arterial road.
Since our design focus is to create a pedestrian-oriented city, the block sizes are approximately 200 feet wide, allowing for a comfortable walking distance. The block sizes help to determine the need for secondary and tertiary streets throughout the site.
Close attention was paid to population density regarding arterial streets and residential streets. The program for arterial roads consists of ground floor office buildings, which are mostly public, and retail. The tertiary streets function as residential streets in more privatized neighborhood areas.
To discourage the use of the vehicle, we have incorporated two forms of mass transit within the site. The first is the Atlanta Beltline, while the second is a trolley system that moves throughout the site.
Pedestrian streets, green streets, bike lanes, and jogging trails have also been incorporated into the design.